Good morning, students. In this session, I'm going to explain about how to implement optimal binary search tree with help of dynamic programming concept in C language. Okay, so let's discuss about what is the concept of optimal binary search tree. After I will explain the programming concept. Okay, first of all, we should know about what is the concept of binary search tree. So, binary search tree is a binary tree in which the left element should be less than the root node and the rightmost element should be greater than the root node. Okay, so these are the condition of the binary search tree. And we can implement the optimal binary search tree. With help of this optimal binary search tree, you can able to efficiently search the given element from the binary search tree. The optimal binary search tree is a binary tree which takes less comparison than the binary search tree concepts. Okay, so for example, if we have n keys are there, we need to find the optimal value with help of this catalog number. Okay, for example, if n is equal to 3, if you want to find how many possible trees if you can draw means you can substitute this n value, this formula you can get. That is 2 into 3, n is equal to 3, then C 3, 3 plus 1. This is for NCR. If you can substitute this value, you can get 20. 63, NCR of 63 is equal to 20. The 20 by 4 is equal to 5. So if n is equal to 3, okay, the given key elements or 3 elements means you can able to draw 5 binary search trees. Okay, see this is the example. When keys are 3, then these are the possible binary search tree for the given elements. Then we need to find which is the optimum. Based on the frequency of the elements, you can able to find. For example, these key values, I can draw the binary search trees like this. What is the concept of binary search tree? The left element should be less than the root node and the right element should be greater than the root node. So this is the root node. The right element is greater than the root node. And this is the root node. This is the greater than of root node and this is the left child of this. This is less than of this 30. Like that, you can able to draw these 5 possible binary search trees. How to find the optimal binary search tree means we can substitute the frequency level here. Here 10 is the level 1, 20 is level 2, 30 is level 3. Okay, so what is the frequency of 10, 3. So the level of 10 is 1, so 1 into 3. The level of 20 is 2, the frequency of 20 is also 2, so 2 into 2. The level of 30 is 3, the frequency of 30 is 5, so 3 into 5. So you can sum all this value, you can get 22. And consider this is another one binary search tree, no? So what is the level of 10? Level is 1, the frequency of 3, okay, 1 into 3. 30, so 30, what is the frequency? 5, the level is what? 2, so 2 into 5. Then 20 is level 3, then frequency is 2, so 3 into 2, you can get 19. Likewise, you can able to find all the possible binary values. Finally, you can find which binary search tree has minimum optimal value. Which one? So this tree, right? So this is 17. So we can choose this is the optimal binary search tree. Okay. Here, if the n is minimum value, for example, n is equal to 3 means 5 possibilities are there. If n is equal to 4 means when you can substitute this formula, you can get 14 possible binary search tree. Again, we need to find the optimal value of all the binary search tree. Finally, you can choose which is the optimal binary search tree, right? So to avoid this complexity, we can move with the formula. That is the cost of I and j we can able to find with the help of this formula. This is minimum of I less than k and less than or equal to j. Then cost of C of I comma k minus 1 plus cost of k plus 1 comma j. Then summation of I is equal to s equal to I to j and ps. Okay. So initially, if this k, now I have 4 elements and the frequencies are there. Okay, we need to draw the two-dimensional tree. Sorry, two-dimensional array. Okay, for that, if it is a row means you can consider that is 1 to n plus 1, and the column means you can choose this 0 to n. Both are same only. Okay, this is 1 to n plus 1, this is 0 to n. And the initial condition is if I comma I minus 1, that is 1 comma 0, likewise 2 comma 1, 3 comma 2, 4 comma 3, 5 comma 4, all the values you can substitute as 0, the given table. Okay, and if C of I comma I is equal to Pi, that is 1 comma 1, 1 comma 2, 1 comma 3, 1 comma, sorry, 1 comma 1, 2 comma 2, 2 comma 3 comma 3, 4 comma 4. When both the indexes are same, you can substitute the frequency value here. Okay, so based on the above conditions, we can draw the table like this. So this is the main table. See 1 comma 0, 2 comma 1, 3 comma 2, 4 comma 3, 5 comma 4, all the values are 0, and 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, you can substitute your frequency value here. Okay, and here also this is the root table. From the root table only we can able to calculate our optimal value. Okay, so for example, so you know the position of 1 comma 1, 2 comma 2, like that. Again we need to find these values, that is what is the value of 1 comma 2, what is 1 comma 3, what is 1 comma 4, likewise what is 2 comma 3, 2 comma 4, 3 comma 4. Okay, so for that we need to use this formula. So if 1 comma 2 means minimum of k is equal to, you can take 1 to 2. That means k is equal to 1 as well as k is equal to 2. If k is equal to 1 means what is the answer you can get with the help of, with substitute the value here. Okay, the k is equal to 2 means what is the answer you can get. If k is equal to 1 means you can get 0.5. K is equal to 2 means you can get 0.4. Among this, we need to find which is the minimum value here. So 0.4 is the minimum value, right? So when you can get 0.4, when you can substitute your k is equal to 2. So we can substitute this value in the table, that's the cost table, and which k value is there. Okay, because 1 and 2 possibilities are there. Whether it is a 1 or 2, we need to find. What is the value here? K is equal to 2. So I can substitute k is equal to 2 here. Likewise, 2 comma 3 possibilities are k is equal to 2 and k is equal to 3. So k is equal to 2 means you can get 1.0. K is equal to 3 means you can get 0.8. So which is the minimum 0.8. So you can substitute here, and at the table you can write that k value here. Okay, so likewise you can again find what is the 3 comma 4. Then finally 1 comma 4. What are the possibilities of 1 comma 4? K is equal to 1, k is equal to 3, 4. 4 possibilities are there. Among find all the 4 possibilities, we can get the values, that is a 2.4, 2.1, 1.7, 2.1. Among this, which is the minimum? 1.7. So I can substitute here 1.7 in the cost table. Then what is the root table we need to update? What is the k value? What is the k value of 1.7? K is equal to 3. So I can substitute k is equal to 3 here. Okay. Finally, we need to find which is the root. That is 0n. Okay. The n is the root value. That is a tk. So 3. So 3 is our root value. Then you can write, you can draw the left as well as the right. Left is I comma k minus 1. Right is k plus 1 comma j. So I is equal to what? 1. J is equal to 4. K is equal to 3. So based on the given values, you can write t of 1 comma 2 as the left child and r of 4 comma 4 as the right child. Finally, we can construct that optimal binary search tree in this way. So this is the concept, and how this concept to implement with the help of C language I'm going to explain now. Okay, so see, for that I'm going to declare the value here. Okay, the here one weight matrix is there, cost matrix is there, then our root matrix is there, then p matrix. This is I'm going to get the value, okay, the key, and this is my frequency. So this is single dimensional. Okay, so these matrices are the two dimensional values. Then I declared here. So this for loop is enter the number of elements, how many number of elements we need. Based on the n, we can get our key elements, and based on the n also we can get our frequency values. Okay, then the initial condition, so when both the index are same, you can substitute the k values, the frequency of the same index values, and the remaining cost and root values are 0. Okay, so I can print the value here in this way. What is I, what is j, and what is the weight of that matrix, what is the cost of the matrix, and what is the root of the matrix. I can able to print here with the help of the for loop. And next, if I is not equal to j, that means I is greater than j, like that. So you can use this for loops to find um, the optimal value with the help of the formula. Okay, the formula we need to find, we can substitute the k values. If it is 1 comma 2 means k is equal to 1 as well as k is equal to 2. Among this we need to find what is the minimum, right? So based on the minimum value, you can substitute the value in our root table, right? So which is the minimum, you can substitute the value in that root table. Based on this, we can able to find all the remaining fields, that is 1 comma 2, then 2 comma 3, 2 comma 3 comma 4, like 1 comma 4. Use this for loops. Okay, so here we can increase these k values as well as I and j value. Based on the formula, we can find the minimum value, as well as based on the minimum value, you can able to find what is the k value of there. You can substitute the value in that root table also. Okay, so finally we need to find the optimal value, no? So where the optimal value should be there, that is the 0 comma n, that is our n value. Okay, so if it is a column is 0 to n, that is last n value, n position is our root, right? So what is that n value, that is 0 comma n position is there, you can print that node as the root node. Okay, so I'm going to run this program. See, I'm going to enter the elements. So 4 elements I'm going to give 10, 20, 30, and 40. And frequency 2, 4, 3, 5, and 6. Okay. So if it is 0 comma 0 means what is the values are there, you can able to print, and cost and root matrix are 0. Okay, and 0 comma 1, what is that? We need to find the formula, right? K is equal to 0 and k is equal to 1, which is the minimum. 0 and 1, you can choose. 1 is the minimum, that means 16. When you can substitute the formula, you can get, as well as 1 comma 2, 2 comma 3, 3 comma 4. So here I can substitute root is 0 comma 1, root is 1. That is k is equal to 1, I can choose. Then 1 comma 2, the root is 2. K is equal to 2, you can choose as the minimum. 2 comma 3, root is 3. That is 3 is the k is equal to 3 is the minimum. 3 comma 4, 4. Like that 0, 2, 1, 3, 2, 4, 0, 3, 1, 4 you can find. Finally 0 comma 4 also, that is what are the possibilities should be there. 0, 1, 2, 3, 4. Okay, among this we can get 3 is the minimum, so minimum optimal, right? So that is a 226 compared to all other values. So finally you can find the 226 the minimum cost. So root is equal to 3. Okay, so if you know root is equal to 3 means you can able to draw the left subtree as well as the right subtree also. Okay, so the given value, the optimal the optimal value is 226. So in this way, you can able to find the optimal key value in the given binary search tree. So that is, thank you.